Hello, students. You probably are already gotten the handout for this, so you can watch this video to give you some pointers on filling this out. This won't take you very long to do, honestly. So I may have to come up with something else for you to do afterwards. But anyway, so on number 4.27, would you use the atomic number mass? Why is it 4.27? It's just where it turned out. I got this from a book. Where would you use the atomic number, mass number, or both to determine each of the following? So if we want to know the number of protons in an atom, well, that's the same as the atomic number, isn't it? And the number of neutrons in an atom, how are we going to get that? Well, remember that the atomic number is the number of protons, and the mass number is the protons plus the neutrons. So if we need to know the number of just neutrons, how are we going to get that? Well, we take the mass number and subtract the atomic number. So we're going to need both. Get rid of that. Get rid of that. Get rid of that. The number of particles in the nucleus. Well, particles in the nucleus are protons and neutrons. I just need the mass number. And the number of electrons in a neutral atom. Well, if it's a neutral atom, it's the same as the number of protons. So to get the number of electrons, all I need is the atomic number. All right, see if you can do 4.28. Describe the type of subatomic particles described by each of the following. Oh, that's easy. You can do that. All right, so do that. That'll be turned in later. 429 and 30. These are from that white book in the back shelf. That's why it's these numbers. Anyway, we want the name and the symbol of the elements of the following atomic numbers. You just got to have a periodic table, find the atomic number, write down the name, and the symbol. It's that simple. So you'll want to do that table, and it is extended onto the next page. That's not going to take you very long. Then how many protons and electrons are there in neutral atoms of the following elements? So protons and electrons, is that meaning they want us to add them together, or is it just protons, which is the same as electrons? What do you think? I think it's just either or. Or we could add them together, but I think it's just either or. So like for argon, it says 18. 18 protons, 18. Oh, let's do that. Electrons. How about that? It's always going to be the same number. Neutral atoms, it's the same. So do these 431 and 432. And when you're done with that, you may turn those in to whoever is. That's probably Mrs. Wood if it's Tuesday, which it should be Tuesday. Okay. Then on YouTube, I'll link this also on Google Classroom. There is a video of me, once again, explaining how to do electron configurations. What do you think? Can you do it? I bet you can. So watch that other video, and maybe I'll make another assignment to go with that. I'll probably want you to do 5 more. I'll pick 5 more elements for you to do electron configuration for and put that on a sheet. So, or we could add it on here at the bottom. The whole back of this page is blank. Why don't we do on the back? Here, let's add a page. No, not that. I wanted to just, oh, there's another page. There's another page. Okay, here we go. Sorry, I missed that last page. So still, you'll probably need your periodic table for this. Symbol is Zn. The element name is zinc. The atomic number for zinc, if you look on your periodic table, on mine it says 30. I assume yours will say the same. And a mass number of 66. They either have to give you the mass number or the number of neutrons. You've got to have one or the other of those. Don't get mass numbers off the periodic table. Did you hear that? Do not get your mass number off the periodic table. Okay, so you got to have both of those, one or the other of those. Now, here's another thing. The atomic number, right, the atomic number and the number of protons and the number of electrons are going to be the same for this table. Those three are the same. So if this was 30, then this is 30, and this is 30. How are we going to get the number of neutrons? Well, if you got the mass number, you can subtract the number of protons, 66 minus 30, you'll get 36. I'll do one more. Number 12. Isn't that magnesium? Oh, that's really hard to read. I don't know why it's so fat. You can probably write smaller than I can. Magnesium, atomic number 12. We have the number of neutrons is 12. We know this is a 12. We know this is a 12 because the pink columns are all the same. So then if 66 minus 30 was 36, then 12 plus 12 would be 24. And that'd be our mass number. So you got to either subtract the mass number minus the number of protons or add the protons plus the neutrons. Okay. Let's see. Yeah, we can finish that. And that same pinkness will extend down here as well when you're filling out that chart. Now, once you're done with that, then we will do electron configurations, and you can watch my video on that. Let's do an easy one like fluorine. That's F. We'll do also silicon, which is Si. We can do, let's do a harder one. How about cobalt? Cobalt. Let's do a really hard one. A really hard one. How about tin? And one more just for fun. Let's do, oh, I like this one. What is that called? I gotta look. Yttrium. That's called Y. Okay, so electron configuration, those all up. You can use that the arrow blanks diagram that you had. I'll leave a few extras up here on the front table. And you can go with that. So that will be, you'll turn in this packet and the, well, including the electron configurations. For today's work, that's Tuesday. I believe that's Tuesday. Most of you are on a field trip Monday. So it's Tuesday. Good luck. Hopefully I'll be able to see with both eyes. I'll let you know.